Hello, welcome back to my channel. Today we will discuss on VIP questions, chapter 10, mechanical wave and sound wave. Question number 1. A progressive wave equation is given below when x and y are in cm and t is in second. So determine the amplitude, frequency and the speed of this wave. Okay, so if you compare y equals to a sine omega t plus kx, so we know that the amplitude A here is equals to 2. Okay, so because the question said it's still in cm, so it's 2 cm, and the omega here is equals to 2 pi over 0.4, and omega also equals to 2 pi f. So we want to find frequency. Okay, so we cancel off 2 pi, the frequency will equals to 1 over 0.4, therefore it's equals to 2.5 hertz. Okay, next one we want to find the speed of the wave, where we know that speed of the wave v equals to f lambda. Frequency is equals to 2.5, so we need to find the lambda, the wavelength. Okay, where we can use k equals to 2 pi over lambda to find the wavelength, where k also equals to 2 pi over 80. So 2 pi and 2 pi we can cancel, therefore the wavelength is equal to 80, and this 80 is still in cm because the question says in cm. So therefore we substitute into the equation 80 cm, and the answer is equal to 200 and in cm per second. Okay, so the answer is equal to 2 cm, 2.5 hertz and 200 cm per second. Okay, so the answer here is C. Okay, next one. Questions number 2. A progressive wave equation is given below when x and y in cm and also in second. Determine the maximum value of dy over dt when x equals to 0. Okay, what does this value refer to? So dy over dt actually is the velocity. Okay, so we can differentiate it where when x equals to 0, so we substitute y is equals to 2 sine 2 pi t over 0.4 plus x is equals to 0 over 80. Okay, so we know that this one will equals to 0. So when x equals to 0, y is equals to 2 sine 2 pi t over 0.4. Okay, so what happened when we differentiate dy over dt? Actually, we will get the velocity, and if we differentiate, we will get 2 sine. If you differentiate, you will get cos omega t. You differentiate, you will get omega, so you will get 2 pi over 0.4, and then we copy back 2 pi t over 0.4. Okay, so we will get 4 pi over 0.4 cos 2 pi t over 0.4. Okay, so since the question says we want to find the maximum value, meaning that the whole equation cos here must equal to 1 in order to get maximum value. So v maximum we will get 4 pi over 0.4, and the answer is equal to 31.42 cm per second. Okay, so the answer here is actually B. Okay, here is the answer. So it's 31.42 cm per second, and it's a maximum vibration speed of the particle. Okay, so the answer is B. Okay, next we go to questions number 3. Questions number 3. Two waves in a long string are given below where y1, y2 and x are in meter and t in second. Calculate the maximum displacement of the particle in the string when x equals to 0.4 meter and the positions of the knots of the resulting standing wave. Okay, so here they give you y1 and y2, and both actually are moving in opposite directions. Okay, so the standing wave form is equal to y1 plus y2, where the equations, the general equations for standing wave is equals to 2a cos kx sine omega t. Okay, so we substitute 2a, a is 0.02, cos kx, where we know that kx is equals to x over 2, sine omega t, so it's sine 40t. Okay, so this is the equations for the standing wave, where we know that a cos kx is actually the amplitude. Okay, so if we say we want to find the positions where knots, meaning that the amplitude here must equal to 0. Okay, so therefore 0.04 cos x over 2 must equal to 0, cos x over 2 must equal to 0. Okay, so x over 2 equals to cos 0, where is actually equals to pi over 2, or 3 pi over 2, or 5 pi over 2, where we know that when cos 90 we will get 0, or cos 270 we will get 0. Okay, so if we cancel off 2, 2, 2, 2, x will equal to pi, 3 pi, or 5 pi. The positions of knots of this resulting standing wave. Okay, so what happens when x is equals to 0.4? Okay, here they give you, so we can substitute to find the maximum displacement, where the maximum displacement, as I mentioned just now, is the amplitude. So the amplitude here for the standing wave is equal to 0.04 cos kx. So we substitute x equals to 0.4 cos x is 0.4 over 2. Okay, so the answer that we get is 0.039 meter. Okay, so all we can round off become 0.04 meter. The answer is D. Okay, so the amplitude of this standing wave is 0.04 when x equals to 0.4, and the positions of the knot is pi, 3 pi, and 5 pi. Okay, next question, we go to questions number 4, where for these questions, they give you y versus t, where for one complete oscillation here, they give you the period, where the period here is equal to 4. And for graph y versus x, okay, so for one complete oscillation, is actually they give you lambda. Okay, so where lambda equals to 5.0. So these are the informations that we have. Okay, so these questions, they ask us to determine the wave propagation velocity, and also the particle velocity. Okay, so here, if you want to find the wave propagation velocity, we know that is equals to v equals to f lambda. F is equals to 1 over t and times the wavelength. So 1 over t, t is 4 seconds, and the wavelength is given 5 cm. Okay, so the answer here is actually equals to 1.25 cm per second. Okay, so this is the wave propagation's velocity. Okay, next we want to find the particle velocity. So before we find the particle velocity, we need to construct first what is the equations. Okay, so y equals to a sine omega t plus minus kx, where we know that the amplitude here is actually equals to 2 sine, and omega just now we know that t is equals to 4, so it's equals to 2 pi over 4t plus minus k, where we don't have k, but we know that k is equals to 2 pi over lambda. So we substitute into the equations. The lambda is equals to 5 cm times x. Okay, so if you want to find the particle velocity, we need to differentiate dy over dt. Okay, so this is v for particle. So if you differentiate, we will get 2. You differentiate sine, you will get cos. Okay, you differentiate omega t, you will get omega. So I substitute here 2 pi over 4. And we copy back the equations. Okay, so from the questions given, When t equals to 0 second, x is equals to 1.2. So we substitute into the equations where v equals to 4 pi over 4 cos 2 pi over 4 and t is equals to 0 plus minus 2 pi over 5 and x is equals to 1 over 2. Okay, so therefore we will get pi cos, okay, this one is 0, 4.8 pi. So if we press calculator, we will get 2.5 cm per second. B, okay, where the wave propagation velocity is equal to 1.25 cm per second square and the particle velocity is equal to 2.5 cm per second square, and this is the equations for this progressive wave. Okay, so next we go to questions number 5. Okay, questions number 5 is the following equations represent a wave motions where y is equal to 0.4 sine 314t plus x over 0.15, where y and x in meter and second. Calculate the speed of the wave. Speed of the wave meaning that we want to find v equals to f lambda. Okay, so if you compare y equals to a sine omega t plus kx, so we know that omega is equals to 2 pi f and also equals to 314, where the frequency that we will get is actually equals to 314 over 2 pi. Okay, and from the equation also we notice that k is equals to 2 pi over lambda and k also equals to 1 over 0.15. So our lambda will equals to 2 pi times 0.15. Okay, so we substitute into the equations where v equals to f lambda, f is equals to 314 over 2 pi, and the lambda is equals to 2 pi times 0.15. Okay, so 2 pi and 2 pi we can cancel, so therefore the speed of the wave is equals to 47.1 meter per second. Okay, so the answer is actually equals to C. Okay, and it is to the left. How we know it's to the left? Based on the equation positive. Okay, so the positive here meaning that it is propagate to the left. Okay, it is propagate to the left. So the answer is C. Okay, next questions we will go to questions number 6. The amplitude of the air vibrations at the distance of 9 meters from the point sound of the power 12 milliwatt is 3 cm. Calculate the amplitude of the air vibrations at the distance of 5 meters. Okay, so we know that I, the intensity, is equals to power over area, or we can write it as P over 4 pi r square, and intensity also is inversely proportional to r square and also directly proportional to amplitude square. Okay, now the information give us that the amplitude is equals to 3 cm when the radius is equals to 9 meters. So we want to find the new amplitude when the radius 2 is equals to 5 meters. Okay, so we can use the relationship between the amplitude and the radius, where amplitude 1 over amplitude 2 equals to R2 over R1 because it's inversely, and then remember to square for both. Okay, so but square and square later we can cancel off each other, so we just substitute into the equations where amplitude 1 is equals to 3 cm, amplitude 2 is the value that we want to find, R2 is 5 meter, and also R1 is 9 meter. Okay, so our A2 is equals to 5.4 cm, because here is still in cm. So the answer is C. Okay, so last questions for this part is question number 7. A source of the sound emit wave at a constant of the constant frequency. Okay, at the distance of r from the source, the intensity of the sound is I. What is the distance from the source when the intensity is 4I? Okay, so as I mentioned just now, intensity is inversely proportional to r squared. I1 over I2 is equal to R2 over R1 squared. Okay, so I1 is 1, I2 is 4I, R2 is the value that we want to find, R1 is equal to R. Okay, so I and I we can cancel, therefore R2 over R is equal to third 1 over 4. Okay, so R2 is equal to third 1 over 4R. So finally, the answer that we will get is equal to 0.5R. So the answer is A. So that's all for today. See you on the next video. We will continue discuss on chapter 10 part 2. Okay, thank you. Bye.